Welcome to Ask and Learn.
We have a device filled with mercury, and it's at room temperature. For part A of the problem, we need to find what the resistance value is of this mercury. So we know that the formula for the resistance R, that's equal to the resistivity rho times a length L of the material divided by the cross-sectional area. And so next, we're going to write out the formula for this area A. So in our case, this area A is going to be equal to pi times d squared divided by 4. So now we can rewrite R as R is equal to rho times 4 times L divided by pi times d squared. So now we can calculate this resistance by plugging in rho and then we plug in L, then divided by pi times d squared. And so we'll get a resistance of 1.22 ohms. So next, we know that a heartbeat causes the arm to expand, and it causes a change in the length of the tube, which is given as 0.04 centimeters. And we need to find the fractional change in resistance whenever this heartbeat occurs. So the expression for the volume of the mercury, we can write this as an initial length L times the initial area, which we'll call A of I. And then after the arm expands, this volume is to remain constant. So this final length times this final area should be equal to the initial volume. So now we're going to write out the formula for the final area. So this is going to be equal to the initial length times the initial area divided by the final length. And we also know that the fractional change in resistance, we're going to call that the change in resistance divided by the initial resistance. And so we can write this also as R of F minus R of I divided by R of I, which we can then also write this as R of F divided by R of I minus 1. Now, since we know the formula for resistance, we're going to rewrite these equations in red. So we're going to plug in terms for resistance, and we're going to say that the fractional change in resistance is now going to be equal to rho times L of F divided by A of F, all divided by rho times L of I divided by A of I. and all that minus 1. And then we can simplify this as L of f divided by A of f times A of I divided by L of I minus 1. So now we're going to substitute in an expression for A of f using what we know. So now this now becomes L of f divided by L of I times A of f divided by L of f. And then times A of I divided by L of I, all minus 1. And then we simplify this as L of f divided by L of I squared minus 1. So now all that's left is to use this equation here for the fractional change. So for L of f, we can plug in 100.040 centimeters squared. So we don't square that. So all this is going to be in parentheses. So we have the numerator and the denominator. We're going to plug in 100 centimeters for L of I, and then we square all of this, and then minus 1, and then this will be equal to fractional change of 8 times 10 to the negative 4.